And this is my first opportunity to speak to a Ukrainian Scala group. So hello, everyone. Hello, everyone from London. Thank you. I've been traveling today, so I'm actually in public transit now. So it's not the best place to be getting a meetup, but I'm very happy to be here. Tonight is I'm going to run through a live coding session of an interactive functional game. Because one of the things that you may have noticed about Alexandra's presentation is that when it comes to programming with pure functions, it's pretty easy to do that in the small. So if you have a function that used to return null, it can now return option. If you have a function that used to throw an exception, it can now return an either. But sometimes it's not very obvious how we can use these same techniques to write our entire application. And also, even if we can do it, can we get real benefits from that? And I hope Alexandra's presentation at least gave you a sneak peek to the answer to that second question, which is yes, there are real benefits to be had by doing pure functional programming in Scala. Very easy concurrency. You get versions of try finally that work across asynchronous sections and work in the presence of interruption. You get parallelism and racing and all these wonderful, really fast, highly optimized features out of a library like Zio that you simply can't get with plain old imperative Java or imperative Scala. Now tonight we don't have time to demonstrate all those features, so what I'm going to focus on is just showing you how to do basic I/O. So basic input-output. Can you do purely functional input and output? And the answer is you can do that. And I'm going to show you how tonight by building a purely functional game. So this is going to use the Zio library. You can see here I've got a file open. And the game we'll be building tonight is called Hangman. So we're going to go and run through this. We're going to implement all of the things that have yet to be implemented. You can notice a few things here. First, we're importing scalaz Zio, so we get everything in Zio, including the I/O monad, as well as assorted data structures like ref and promise and other things we won't be using tonight, which are very powerful and help you build high-performance concurrent and asynchronous applications. We're also importing everything inside this console package here, which gives us the ability to read and write input and output from the console. And finally, we're going to use this exception type because as we do console input and output, there's always the possibility that we get an exception somewhere. So this is our application. This extends app, and this app here is actually Zio's app. So this is not the app that you'll find in Scala. It's Zio's app. And what Zio's app gives you is the ability to write a purely functional main function here. So you write this, and then what's going to happen later is Zio will translate this I/O program here, this value here, into effectful operations that make your purely functional program actually do something with the external world. Like Alexandra covered earlier, I/O here is a model of a program. It's an immutable data structure, and it models a program that can fail for one of these reasons, or it can return one of these values. So this I/O program here cannot fail, and it will return an exit status. So when you're looking at all these types here, always keep in mind that what we are building here is nothing more than values that describe effectful programs. That's why I've got lots of programs here like getChoice and Hangman Game and ChooseWord and so forth, which are simple vals. So these are not defs, these are vals. And that's because in the world of pure functional programming, everything is a value, including your effectful programs. So that's why these things don't need to be defs, they're just ordinary vals. This is the state of the game. So the game of Hangman is pretty simple. What happens is It's going to choose a random word from this dictionary, and then it's going to ask you your name, and then it's going to allow you to guess what that word is by choosing letters. And if you guess all the letters correctly in time, then you win the game. But if you make too many guesses, then you lose the game. So this demonstrates in doing IO. We're also doing some random number generation. We're also doing recursion. We're doing loops in a purely functional construct because there's a main game loop, and I'll show you how to do that. And it's a nice, simple way to sort of tie together a lot of concepts that you saw earlier tonight in Alexandra's presentation. So let's get started here with Hangman Game. This is the entry point for the application. You can see here our run function just calls Hangman Game. So Hangman Game is the entry point for the application. This program is going to not return anything useful because it's the whole game, and we don't need to get information out of the game. And it's going to potentially throw an I exception if something happens during console input-output. So the first thing we're going to do is open up a for block. For blocks are very common. These for comprehensive flat map instructions by the Scala compiler, followed by a final map operation. So this is nothing more than syntax sugar for a bunch of flat maps, followed by a final map. The first thing we're going to do is call the putStirLine function, which is defined inside console, to print out a welcome message. After we print out a welcome message, what we're going to do is retrieve the name of the user. So I've created a helper program here, which is going to retrieve the name of the user. So what I'm going to do is I'm going to insert this in the for comprehension, and I'm going to bind the result of that to the variable name. In the case of putStirLine returns unit. So I don't need to give that a name, so I use underscore there. At this point, we've printed out our first message, and we've retrieved the name of the user. Oops, sorry, get name. And so now we'll welcome the user to the game. Now notice one thing here, because all of these are being translated to flat maps, this flat map to this, flat map to this, we are building a value here. That's all we're doing. We're not actually running effects. We're building an IO value here. So we're composing all these IO values into one that we end up returning. This represents our total composed program. It's composed from all the pieces. After we retrieve the name, what we're going to do is we're going to choose one of the words from this dictionary. And to help us, I've created a little helper function called choose_word. So we'll implement these two later. For now, I'm just going to write word, and I'm going to call choose_word here. And you can see that this program returns a string. So right now I'm binding that string to the variable word so I can use it in subsequent computations in the for comprehension. After I've chosen the name of the user and the word, I can now create an instance of the state data structure. This state data structure will contain the name of the player, the number of guesses so far as a set of characters, and the actual word that was chosen in the beginning of the game. It has some very simple methods in here, which are pure functions, which simply count failures and decide if the player lost the game or if the player won the game. We use these shortly. We'll start off with an empty set because the user has not chosen any characters. Note here how I'm using the equal sign instead of the backwards arrow. And that's because this will be expanded by Scala into value state inside the flat map generated by this part of the for comprehension. So this is useful when I need to simply create variables to hold values, and I don't need to compose I/O programs together. This over here is not an I/O program that I need to compose together with this one, so I don't need to use the backwards arrow here. Instead, I just use the equal sign. Now we have the name and the word and the state, and so now we can begin the main game loop. So to do that, we call game loop with the state. And this returns another state, which we're just going to ignore. I'm going to use an underscore for that. All right, so now let's go back and you can see here, we're composing together all these things using flat map and a final map here. And we've built up our program from smaller programs. And each one of these smaller programs, they return something or possibly they fail along the way. Let's implement some of these helper methods. The first one I'll implement is getName. And for this one, I'm just going to prompt the user for his or her name. I'm going to retrieve the name using getStirLine. And then in this case, I'm going to yield the name to the final thing in my for comprehension. So my little program here, which models a print line followed by a get line, will end up returning the name of the user as string. And might fail with an I/O exception because one of these might throw an I/O exception. Actually, this one here might throw an I/O exception. Choose word. So to choose word, I need random number generation. Well, we have it in Scala too. Scala, we tell random, and I can call next int here, and I can specify the maximum. But the issue with this is next int is not a function. And it's very, very hard to combine functional programming and non-functional programming. So instead of trying to do that, we're instead going to make our own version of next int that is purely functional. Dio makes this very easy to do. All we have to do is say we're going to return here IO. In this case, we have to choose the error type. The error type will be nothing because it is not possible for next int to fail. It will actually always succeed. We will return an integer here. That will be between 0 and max. And we can't call this directly, but we can call a method on the companion object of IO called sync. And sync will allow us to take this full foreign code and import it into a data structure that will describe the action of performing this effect. So this IO here is an ordinary value that merely describes the action of performing this random number generation. It doesn't actually do anything other than describe it. So this will return a pure IO value here. Now for choose word, what we can do is we can call this int using the length of this dictionary. Now this will give us an IO. So we can use a for comprehension here. And now we can look up the word using this int. The function on list is a list, an ordinary list called lift, which can lift up a list into a function that when given an integer will return an option. So we'll call that on int. We'll get back an option here, an option of a string, and then we'll call get or else. In the event that the index is out of range for the list, it means we have a bug in our program, a bug in nextInt, or maybe we just passed the wrong length to the nextInt method because the integer was outside the range of this list. So here we're using lift, so we get an actual function out of list. If you use the ordinary apply method, it could throw
We lost John. Hope he'll be back. Let's upload the limited part. Yes.
Oh, I sent a message and he didn't but maybe another link to open out. Maybe I can turn off video, but I don't know. Yeah, okay. So that's why I asked you to record a video. But it's okay. We will write the book together starting at November. Mostly, and also some functional topics. And to improve my writing skills, and also writing about what I'm doing. Like improving skills in programming. So I don't think I like communication skills.
Now you found out
No, before.
in general.
In general. I'm always alone. And also I like work.
If you're working sizable projects, you have to deal with people all the time.
Yeah, but yeah, but I'm trying to change to be more. Yeah, I don't think not don't think nothing bad happens if I do this.
So on your mind,
Um,
side effects.
yeah, side effect.
Shall we support?
Maybe he'll use his phone, but
I might have
maybe we
break.
break for 5 minutes or on what time we should finish?
Around 9.
9? Okay.
We just have a break, so it's kind of weird to come another break. Just wait a few more minutes. Not maybe can do a video or something that we can send later.
Oh yeah.
Scenario.
So we'll wait a few more minutes, and if John doesn't show up, we will do another break. Worst case scenario, he might just record the talk and which will share like
So now we're more relaxed.
Well, thinking what should be improved in the next episode. And I know. So I work hard and also, but John was busy and on next week we will work together. So I mean, next week probably will be not at John level, but much higher.
It's good. I mean, just like trying to not rush. I started rushing in the middle of first you started reading and then started rushing in the middle. Start skipping. I guess it's kind of more nervous to forget something.
So the problem was that we always change, and I did notes, and I forgot the point. So the main point. So, but reading is not nice, and I try to remember. But
Yeah, no, it's okay. I mean, if you forget, just kind of move on. Doesn't really matter. People don't know what is working on. So you
it's
just,
like
just pretend that you're like fine.
I have my previous boss. He's not him, but my previous boss always says, "How you know what you don't know? Who is this?"
No one you don't know, but no one else you know.
okay, I think we'll have another break and we'll see if John comes back a bit later. If he can finish the talk. Sorry about that. So you can finish the pizzas.
Да, просто у него Я, наверное, ну, понимаю, не знаю.
Hello. Where did I lose you? Hello. How far back did I lose you?
Hi, we are here.
When did I drop out?
It was choose word.
At choose word?
Nice picture.
So I lost you at choose word?
Yeah.
All right. Well,
We don't see it.
let's see. The original choose word, right?
Yes,
All right. Oh, okay. So let me.
speak from your heart.
All right. Well, let's do this again. I finished everything. Let's- no, that's not necessary. Let's go back and do this again. All right, and I'll go ahead and keep an eye on the background video. So if I lose you again, it's going to be less time. I'll hear the result of all our hard work. See? All right, let's go back in time. Really, we missed all this, right? Or did we get this?
Yes, we did.
Oh, good. Okay, so we got this. And here's where I dropped out, right? Or did I finish this?
Yes.
I finished this?
Yes.
All right. And then I went on from here to here. Did I start coding this? We'll start here. Is that okay with everyone?
Yeah.
All right. So here's the main game loop. And what we want to do is, given the old state, we'll produce the new state. So we're going to open up with the for comprehension. And inside this game loop, what we're going to do is we're first going to get a choice from the user by calling this helper function, which will return a program that returns a character. So we'll call this the guess of the user. And this will be translated into the flat map, as I mentioned before. After we get the choice, what we need to do is update the state. There's a couple of ways we could do that. One way is to use this state copy, and this works because inside this flat map here, going to have to we'll insert this as a val. So we'll have to use a new name here for state, and then we can refer to the old state, and we can create a copy, mutable, of course, with the specified guess. added guesses, I guess, guesses is what it's called, added to the set. So we could do this, wanted to. But I don't like the fact that after this point in our program, we have two values of type state. So we might accidentally refer to the old one. So in order to remove that possibility, I'm going to show you this technique, which I quite like, which is to take this value here and lift it up into a program using IO now or IO point. So IO now or IO point can take a value and they can turn it into a program which returns that value. So I'm going to call IO now here. The difference between now and point is strict versus lazy evaluation. And this is already going to be needed, so I don't need lazy evaluation. I'm just going to use strict evaluation here. And so what I'll do is I'll copy the state to produce the new state, and then I'm going to lift that up into a program, so now I can flat map over it in Scala syntax in the for comprehension. So now I have essentially what is a new state here, which shadows this one. This is not updating any variable. This is just inside a nested flat map. This state, now I can only refer to this state, the updated state, which is exactly what I want. Now the next thing I need to do is to check to see if the player won or lost. I can rely on these helper functions called player and player lost. So I'll do that down here. And I'm going to put this is not correct. I'll explain to you why in a second. If the player won, then what we'll do is we'll print out a congratulations message. On the other hand, if the player lost, then we'll print out condolences message. But we don't want to be too excited about that, so we'll change that to a period. Otherwise, if the player did not win and the player did not lose, then there's a possibility they guessed correctly, but there's also a possibility they guessed incorrectly. And we would like to be able to tell between those two cases. So what I'll do is, if state word contains the guess that the user made, then we'll print out one message. And otherwise, if the state does not contain the state word does not contain the guess that the user made, then we'll go ahead and print out a different message. I guessed wrong, but keep trying. Now I mentioned that this doesn't really make a lot of sense right now. This is actually the wrong thing to do, and the reason is this produces a program here, just sitting out here in the middle of nowhere. And when this is translated, actually, this won't even compile. We're going to have serious errors. All of our I/O programs need to be to the right, this left arrow. And that's because the way this will be translated by Scala is into this flat map, using this as the parameter name, this flat map, this is the parameter name. And so Scala is expecting us to continue this pattern. So what we're going to get out of all of these branches right now is a unit. So I'm going to ignore that. And then I'm just going to produce all these programs inside these conditionals here. Now, when you're using conditionals here, keep in mind that you need to return the same type of every branch. And in this case, we're doing that. Every one of these returns a program that returns unit. So we can go ahead and stick this to the right of this arrow because we're returning the same type of program in all the different cases. And right now that program returns unit. But unit is actually not enough. And the reason for that is we need to know if we should continue the game loop. So instead we want programs here that return a Boolean value so we can know whether or not to loop. So what we'll do, we'll change this from underscore to a variable called loop. And this will be our sign whether or not the player wants to loop. So in the case the player won, then we don't want to loop anymore. So we want to turn this program, which returns units, into a program that returns false. How we can do that is we can map this program. When you map over an IO, you're mapping over the return value. So what we can do is map this. We can ignore the unit produced program. And now we can return the constant false because we don't want to loop. This is a very common pattern. In fact, it's so common that there's a helper method on the IO that lets us do exactly this. And it's called const. So let's go ahead and use that. Const false from this branch. If the player lost, we'll return a program that returns false here. And in both these other cases, both this one and this one want to return true, so we'll do const true. Now we have that loop variable. The next thing we need to do is use it. So down here, what I'm going to do is I'm going to write this incorrectly at first, and then we'll fix it. So if loop is true, then we want to continue the game loop. How do we continue loops in functional programs? We recurse. So let's go ahead and call game loop here on the new state. And then we need to do something else. If loop is false. And remember, we're using conditional here. So two rules about conditional. First off, we're going to have to return the same type of program from every branch. Second off, of course, we're going to have to put this to the right of the left arrow. So game loop will return the new state. So I'm binding that to the variable state. And then in our else branch, then I need to produce the same type of program here, which means I need to produce a program that returns state. Well, I don't have any new state, so I just need to produce a program that returns this old state. But I can do that simply using IO now. So now I've produced a program that returns the state produced here. And then finally, I'm going to yield this state out of here, so my game loop will end up returning the final game state. So let's review this logic. We get the choice. We create a new state that adds that guess to the set of guesses. And then if the player won, we get a congratulations message, and we turn this into a program that returns false because we don't want to continue. If the player lost, we print out this message and return a program that doesn't want to continue. And then in these other cases, we'll return a program that does want to continue. However, we're going to distinguish between the case where they guessed correctly and the case where they guessed incorrectly. And then if the user needs to continue because the game's not yet ended, we'll call game loop on state to produce the new state, which we end up returning here. Otherwise, we'll just immediately return last value of state that we have produced. All right. So one thing we need to do here is dictionary is referred to previously. So I'm going to turn this into a lazy eval. All right, so let's go back and implement this helper. Actually, let's do one more thing. We need to render the state of the game to the user. So let's do that right here after we've produced the new state. Render state returns a program that returns unit. We don't need the unit value, so we'll just ignore that. We'll call render state with the updated state. And we'll also do this at the very beginning of the game. So we'll do that right after we create the state. We're going to call render state just so the user can see how many characters there are before they're asked to guess. All right, so now let's go ahead and implement getChoice. So for getChoice, the first thing we want to do is prompt the user to enter, make a guess. And then we'll return a line of input from the console. But this line of input may not contain a character. So we're going to have to do some validation. So in order to do that validation, what we're going to do is we'll create another program over here to the right of our left arrow by matching against line to lowercase, trim, head option. So note here, I'm only using functions. I'm trying to only use functions. Head is not a function. Of course, it can throw exceptions. Head option is a function. It forces me to deal with both possibilities. The possibility the user entered something and the possibility the user did not. If the user did not enter anything or just entered a bunch of white space, for example, then what we'll do is we will print out a message saying he did not enter a letter. Otherwise, we'll do something else. In both cases, we want a program that returns a character here. So what we have to do in this case is we have to recurse. We have to call getChoice again. So I can do that in a for comprehension if I want. But this pattern is very common, where you do one thing and then you ignore its value, and then you do a second thing. It's so common there's an operator for it in Zio, which looks like this. And it just means do this thing and then do the next thing and return the thing on the right. So I'm going to write this like this because it's more compact. Now we're returning here, this program here returns whatever this returns. So this compose program here will return a character because getChoice returns a character. Now from this branch, we need to return a program that returns a character. We already have a character. So we can just return a program here that immediately returns the character, which was inside there. And then from here, we'll go ahead and yield that character out of the for block. So at this point, I think we have all the pieces of the puzzle now. We'll do one more thing. We'll simplify this. This returns a program that returns an int. So we're going to map over this. And then we'll just do everything in here. We don't need a for comprehension. It's a little more complex than we need. So this is a simplification. This takes our program that returns an int, and we're mapping the int into a string. So we end up mapping the program of int into a program of string. All right, so we are totally ready to run this program. But let me before I do that, let's just walk through it one step at a time. So the entry point is here. Main function that we can call from Java and SBT and IntelliJ IDEA and everywhere else. So we don't have to worry about that. And then in here, we're going to end up returning a program that returns an exit status. And there's this basically converts a failure into exit status of 1 and success into exit status of 0. You don't need to worry about this. Basically, the only thing we're doing in run is the Hangman game program. So let's go back there and look at that. We print the welcome message. We get the name of the user. We greet the user. We choose a word. We create the initial state of the game. And we render the state of the game, and we enter the main game loop. In the main game loop, we get the choice from the user, which we just saw. We implemented that. We create the new state. We immediately render it based on the new state, based on the choice that the user made. We figure out whether or not we should loop based on whether or not the player won or lost, or neither. And then if we're supposed to loop, then we go ahead and call this function recursively. So Zio is stack safe. You can call it recursively as often as you want, even in infinite loops. And it will not stack overflow. It may overflow the heap if you're not using tail recursion. So tail recursion is an important concept for functional programmers to learn, but we don't have time to explore that here. This produces the new state, and finally game loop just returns that state. And the other main thing is the choose word, which we looked at before. We looked at importing this foreign code into a pure value that represents a program that merely describes the effect of generating a random number, but does not actually do anything other than compute this value, which is a model of a program. And we looked at this relatively simple program, which in fact we can simplify using that operator I showed you before. You don't even need to name this because we're just going to immediately return this. So we can simplify that quite a bit. Now let's go ahead and run this program and just make sure that we don't have any bugs. All right, so now we can call run with, say, nil. This is intended to be used as a main program, so it expects command line arguments, which we aren't using. So I'm just going to pass nil there. And what we get back, of course, is this IO. So all our program does is return this IO value, which is a model. It's an immutable value that describes an effectful program. But of course, nothing actually happens. If we want to run this IO, then we have to call another method, which is defined on runtime system. So we have to create a runtime system here, and then we have to use that runtime system to interpret this data structure into the effects of our program. So in the REPL, there's a very simple way to do that. Just add .unsafe_run to your IO value. So we'll call run nil .unsafe_run, and then let's see if this program works. Okay, well, I think I'm going to lose this game, but yeah, I'm definitely going to lose this game. I have no idea. Yeah. What's that?
Aspect.
Aspect. Oh, okay. There we go. All right. You narrowly saved me from losing this game that we've created. All right. So there we have it. This, you can see here that this program was interactive. It did console input output. And it was also purely functional. And also, the very first time we ran the program, it just worked. There were no bugs in our program. And part of the reason there were no bugs in our program is because we programmed using pure functions. Our functions could not throw exceptions. They could not return null. They're all deterministic, and they're all pure. And this is a very common experience that I have with functional programming. If I do some non-functional programming, then I have much higher bug rate. But when I do something using pure functional programming, then I actually have very, just almost astoundingly low bug rates. And that's because when you compose your program from pure functions, it's much easier to reason about it locally. And of course, the types of purely functional programs, they convey a lot of information. I didn't talk about that today, but there's a keynote that I just did actually yesterday or the day before, I can't remember, but that's coming out soon. I encourage everyone to check that out because I talk more about some of the actual practical benefits of pure functional programming. And those benefits are twofold. So they obviously help you write better software. So you can reason about your programs, you can refactor your programs, you can test them more easily and so forth. But beyond all of that, there are very compelling reasons why you might want to investigate using Zio, and that could be anything from concurrency to having very strong support for asynchronous programming, to having try finally, a version of try finally that works in all cases for synchronous code and asynchronous code. It could be the scheduling facilities of Zio, which allow you to repeat and retry actions. It could be any one of a number of different things. Zio is a very powerful library that lets you build applications that solve real-world problems in a purely functional way. And you can do it in less code with stronger guarantees, usually, that's my experience, than you can by solving the same program using imperative Scala or imperative Java. So I hope you've enjoyed this. I thank you again for attending this and attending Alexandra's presentation earlier. And if you're interested in learning more about functional programming, then YouTube is a great resource. I also have a blog at dgoes.net. You can follow me at Twitter. My username is jdgoes. And actually, I'm hoping that maybe the next Scala UA, which occurs in Kyiv, right?
Yes.
Yeah, so I actually hope that I'm able to attend the next one. So maybe I'll be a speaker at this event there and have a chance to meet you all in person. Thank you all for coming. Do you have any questions before I wrap up?
Yes, we have a few questions if you still have time. So someone asks why Zio is a separate library and not part of Scala Z8.
Yeah, so the reason for that is not everyone uses scalaz. Some people use cats, and some people don't use cats or scalaz. So in order to make Zio very useful to all types of programmers, whether you're using cats or whether you're using scalaz, or whether you're using cat effect, or whether you're not using any of those and you just use Akka or maybe just Future, Zio is a standalone library that has no dependencies and can be used very easily in just about any type of application. Now that said, Scala Z8 depends on Zio. So Zio is actually a part of Scala Z8. But the reverse is not true. So Zio is not going to bring in any dependencies. It's just very small, very lightweight, and you can use it very simply in whatever type of app you're building. Whereas Scala Z8, of course, brings in the rest of Scala Z. So it includes lots of type classes and lots of powerful functionality. Also can be a little confusing to some developers who are not used to it. Whereas Zio has no type classes. Everything is a concrete method on a concrete data. And all these methods have very good documentation and examples. So it's intended to be used by a broader audience than who will ultimately use Scala Z. Good question.
Okay, thanks.
Any others?
Yeah, a couple more. Actually, one is very good. Here, I think I already answered. So I was interested in using of cats effects. Was that like a good idea?
Yeah, so Cat's effect provides type classes, and Zio provides instances of those type classes for the IO data type. That means if you're using Cat's effect, you can choose to use Zio as well. You can use Zio instead of the built-in IO monad that's inside Cat's effect. The IO monad effect is simple. It does have a number of drawbacks. So I would recommend actually not using that type and either using Monix task, which is a better implementation of those type classes, or Zio, which has a few features on Monix task, I would argue. So in any case, if you use Cat's effect, you can use that with Zio. And if you use libraries that rely on Cat's effect, for example, FS2 or Doobie or some of the other libraries out there, then you can also use those libraries with Zio.
All right. So what's interesting is Zio production ready. Can you use it for like critical programs software?
It is currently being used in production by a number of companies. But it's still very stable and has very, very low bugs. There's only a couple of no bugs in the library, and it is actually used in production at quite significant volumes. So I would say it is production ready. That said, 1.0 is just a month or two around the corner. So when 1.0 comes out, everything will be very, very stable and will maintain that version of the API in a backwards compatible fashion until 2.0.
Okay. We have one more question maybe from audience live. Do you have any live question? Okay, John, I think we're kind of out of questions. Thanks for taking your time to share your knowledge. I think it was really interesting to see, especially how we can do a problem like minimalistically in your functional way.
Yes, thank you. Thank you all for coming. And it's a shame I couldn't be there in person to meet you, but at least I got to say hi. All right. Take care. Bye-bye.
Thanks, bye. All right, thanks you everyone for coming. And this wraps up our next meetup. Any ideas, comments?